Good evening. Today is Tuesday, March the 9th. Today in pre-calculus, we looked at vectors in three space. We looked at the dot product and the cross product and several other problems, but I'll share the screen and show you the dot product and cross product here, which are the main parts of what we did. So when you have two vectors, when you have a vector, let's say we can do vector A. Now, when you write vectors in books, they're bold faced, but we'll just say, okay, we'll say vector A, and I'll put the markings on it here in a second, equals, let's say 3, 5, minus 2, and vector B equals 1, 4, and 6. Okay, now, so if we come back here, when you do a vector, if you have it in a textbook, it's bold. But what you can do is you can put your arrow over it. Now, when you have your three coordinates here, or the three numbers, you know it's a vector because you have this sideways V here on the edge instead of the normal parentheses. So if you see this V here, you know, okay, you don't have a set of coordinates in three space, you have a vector. Now what it means is that you go 3 units in the X direction, then you go 5 units in the Y direction, and you go minus 2 in the Z direction. So now when we look at, the first thing we're going to look at is something which is the dot product, which is A dot B, and it's just a dot here. But now you know it's not multiplication because you can't multiply vectors just like this, okay? I mean, you can put them together, but you can't multiply them. So when you do the dot product, it's the first number here times the first number here. So that's 3 times 1 plus 5 times 4, the second number times the second number. So that's 5 times 4. And then the plus the third number, which is minus 2 times 6. Now, if you add all these together, you get 3 plus 20, so that's 23 minus 12, so your answer is 11. Now, the fact that it's 11 means that these two vectors are not perpendicular. If you have a dot product that ends up being 0, then you know that the two vectors are perpendicular, or what's called orthogonal. Orthogonal means they are perpendicular to each other. And that helps in 3 space. In 2 space, you can pretty much tell when you draw two vectors whether they're perpendicular or not. But in 3 space, it's very difficult to kind of visualize that. So you have this here, which tells you that those two vectors are not perpendicular. Now, if you want to find the angle between the two vectors, the formula for that is the cosine. You take the cosine of the angle, whatever the angle is, equals, so we'll call the angle theta here. So you put the dot product on the top, so that would be A dot B. Okay, and we know that is from what we just did. So A dot B divided by the product of the magnitudes. Now, so the magnitudes, you got vector A with its magnitude, and that's, you do the absolute value signs around it here. And then vector B with its magnitude. And the magnitude you find by just doing the Pythagorean theorem extended, okay? So we know the dot product is 11. Now, if you come back here to vector A, you square 3, you get 9. You square 5, you get 25. So 25 and 9 is 34. And you square 2, you get 4. So the magnitude of vector A is the square root of 38. And then you look at magnitude of B. 1 squared is 1. 4 squared is 16, and 6 squared is 36. So 36 and 16 is 52, and 1 makes 53. So that's the square root of 53. Now, so if I put this in my calculator, and you're not going to do this in your head, so I've got 11 on top divided by the square root of 38 times the square root of 53, and I hit enter, and that gives me 0.245, so that's going to be 0.245. And then, so in order to find the angle between them, I would come in here and say, okay, theta equals the inverse cosine, or the angle whose cosine. That's what the inverse cosine means. Theta is the angle whose cosine is 0.245. Now, when you use your calculator, the first thing you do is you make sure that you're in the mode you want to be in. So in this case, I want to be in degree mode. So I check my mode. I'm in degree mode. So I do second quit, and then I can do second cosine of the answer that I just got, which is the 0.245. And I get an angle of 75.8 degrees. So 75.8 degrees. Now, so that I knew that these two vectors were not perpendicular to each other, but the angle between them is 75, so it's a little bit less than 15 degrees from being 90. So, and the closer this number here gets to 0, the closer this angle here would be to 90, okay? Now, so that's the dot product. Now, let me show you. The second thing we looked at is something called the cross product. Now, the cross product is you get it if you look, okay, so we're going to do the same two vectors, A cross. Now the cross is just like this, and now that's not multiplication. That's when you see vectors and you see that X in the middle there, that means the cross product. Now the way you solve the cross product here, you set up this 3 by 3 matrix. If you remember back when we did matrices, okay, so I'm going to put my I, my J, and my K. These are my unit vectors in the X, Y, and Z direction. And I put my vectors, so I would put the 3, the 5, and the -2. And then I would put my other vector, which is 1 and 4 and 6. Now, remember when I do this, so I get my I vector, and I'll go ahead and put my matrix, my vector on it. Now, and I multiply that by the determinant of the minor. Now, remember, the minor is what I get when I cross off the row into column. So in this case, the minor of I is 5 minus 2 and 4 and 6. And then the checkerboard pattern, I put a minus with my J. And then I do its minor, which is, similarly, see, I cross off the row and the column, so I have the 3 and the -2. And then I have the 1 and the 6. And I put my plus K. And I put its minor, and its minor is 3, 5. And 1 and 4. Okay, now remember, if I come down here now and do these 2 by 2 determinants, it's going to be the main row or the main diagonal minus the off diagonal. So I have 5 times 6 is 30 minus a minus 8. So this is 38i. Remember, I'm writing the vector in the unit vector form, okay? Now I've got minus j, so I got 3 times 6 is 18, minus a minus 2, so that's minus 20j. And then I have plus 12 minus 5 is plus 7k. Now, if I want to write this in the three grid combination, it would be 38, comma, minus 20, comma, 7. So that's the 3 number designation, okay? Now, here's the interesting thing about the cross product. The cross product is a vector that is perpendicular to the 2 original vectors. So if I come in here and do the dot product between vector A and the cross product, which is A cross B, then what happens here, if you'll notice, see, I get 3 times 38 okay, plus 5 times minus 20 minus 2 times 7. Okay, and if I look at this, see, so this is 24, so this is 114, this is minus 100 minus 14, which is equal to 0. Okay, now, so you check when you do a cross product like this, you always check and see, and I'm not going to go through and do the B. You can do the B in the same way, B dot with the cross product. You'll show that you get 0 there also. But you should always check, once you get a cross product, check it with the 2 vectors you started with to make sure that you get the 0 dot product, and that will ensure that you performed your cross product exercise correctly. So that's what we've done so far. Now, what we'll do tomorrow in class, we will review the chapter. So we're going to work some review problems. And then Thursday and Friday, we will do the chapter test, which is in your textbook. So you need to do that and get it to me. And we will do all the problems except, if I'm not mistaken, problem 12 and 20. So if you have questions, once again, send me an email. I'll go ahead and stop sharing here now. And if you owe me anything, as I said, make sure that you get it in to me by Friday so that we can put the grade in for the end of the 9 weeks. So hope you're doing fine. And as always, if you have questions, send me an email.